frequently features questions on achievements of Indians in science and technology and the indigenization of technology. To score high in these questions, you need a balanced approach, an introduction, context, relevance, a structured body, clear headers, data, and bullet points, and a forward-looking conclusion evaluating the socio-economic impact. Question 1, 15 marks, 250 words, discuss India's achievements in the field of space science and technology. How has the application of this technology helped India in its socio-economic development? Model answer structure. 1. Introduction. India's space journey, transitioning from transporting rocket components on bicycles in the 1960s to becoming a global space power, represents a remarkable model of indigenous, cost-effective innovation. The Indian Space Research Organization, ISRO, has successfully balanced deep space exploration with citizen-centric societal applications. 2. Key achievements in space science. Planetary and deep space exploration, Chandrayaan missions. Chandrayaan-1 discovered water molecules on the lunar surface. Chandrayaan-3 achieved a historic soft landing near the Moon's south pole, making India the fourth nation to soft land on the Moon. Mars Orbiter mission, Mangalyaan. India became the first nation to reach Martian orbit on its maiden attempt, executed at a fraction of the cost of Western missions, placed at the Lagrange point 1, L_1, studying the solar corona and space weather. Launch vehicle sovereignty, evolution from the basic SLV-3 to the robust PSLV, the workhorse of ISRO, and the LVM-3, GSLV-Mk3, giving India self-reliance in launching heavy satellites up to 4 tons into geosynchronous transfer orbit. Indigenous navigation, the deployment of NAVIC, navigation with Indian constellation, providing independent regional positioning services over India and adjacent regions. 3. Socio-economic development applications. Sector. Core application. Tangible impact. Agriculture and food security. Earth observation via RISAT and resources at series, Fasal project. Crop yield estimation, soil moisture analysis, and warning systems for locust attacks or droughts. Disaster management. Real-time monitoring via INSAT systems, tracking tropical cyclones. Drastic minimization of casualties. For example, advanced tracking of severe cyclones allows mass evacuations with near-zero mortality. Resource mapping. Bhuvan Geoportal. Groundwater prospecting, forest cover monitoring, and developmental planning under MGNREGA. Social infrastructure. Tele-education and telemedicine determine its progression. Model answer structure. 5. Introduction. Formulated by Dr. Homi J. Bhabha in the 1950s, India's nuclear energy roadmap was strategically engineered to achieve long-term energy security by utilizing the country's vast indigenous resources, limited uranium reserves, less than 1% of global reserves, but massive thorium deposits, approx. 25% of global reserves. 6. The three-stage strategy. Stage 1. Pressurized heavy water reactors, PHWRs, fuel, natural uranium, moderator, heavy water. Achievement. Fully indigenized by Indian scientists. It generates electricity and yields plutonium-239 as a byproduct. Stage 2. Fast breeder reactors, FBRs, fuel, plutonium-239 extracted from stage 1 mixed with depleted uranium. Achievement. The prototype fast breeder reactor, PFBR, at Kalpakkam utilizes unmoderated, fast neutrons. This stage breeds more fuel than it consumes. Thorium blankets will eventually be introduced here to produce uranium-233. Stage 3. Advanced heavy water reactors, AHWRs, fuel, thorium-232 mixed with uranium-233. Status, experimental, design phase. This is the ultimate goal to unlock India's thousands of tons of coastal monazite sands, thorium. 7. Constraints and challenges. Technical complexity. Fast breeder and thorium utilization technologies are highly complex, leading to timeline shifts in commercializing stage 2. Capital and incubation periods. Nuclear plants require significant upfront capital expenditure and undergo long gestation periods before becoming operational. Public and geopolitical concerns, challenges around land acquisition, civil liability for nuclear damage laws, and strict international regulatory oversight. 8. Conclusion. Despite delays in transitioning to the third stage, India's parallel focus on domestic PHWR construction, the indigenization of nuclear subsystems, and participation in global fusion projects like ITER underscores its status as an advanced, self-reliant nuclear state. Question 3, 15 marks, 250 words. How has applied biotechnology contributed to improving the living standards of farmers in India? Discuss the associated challenges and regulatory mechanisms. Model answer structure. 9. Introduction. Applied biotechnology involves using living organisms or cellular processes to develop targeted products. In Indian agriculture, biotechnology has emerged as an important tool to address structural vulnerabilities like pest infestations, soil degradation, and climate change-induced weather irregularities. 10. Contributions to farmers' living standards. Yield enhancement and pest resistance. The introduction of Bt cotton, the only commercially approved GM crop in India, converted the country from a net importer to a leading exporter of cotton by minimizing losses from the bollworm pest. Climate-resilient crops. Indian scientists have developed climate-smart crop varieties through molecular marker-assisted breeding. Examples include Samba Mesuri, flood-tolerant, submergence-resistant rice variety. Drought-tolerant varieties of pulses and oilseeds. Biofertilizer and biopesticide. Innovations like rhizobium cultures and trichoderma-based formulations reduce farmers' input dependency on expensive chemical alternatives, protecting soil microbiology and cutting production costs. Biofortification. Developing nutrient-dense crops, e.g., zinc and iron-rich rice and pearl millet varieties, helps tackle hidden hunger in rural communities while increasing the market value of the crop. 11. Associated challenges. Monopoly and seed pricing. High costs of proprietary seeds can create economic pressure on small and marginal farmers if market prices are left unregulated. Environmental and biosafety concerns. Potential risks of gene flow, superweeds developing resistance, and long-term impacts on non-target soil organisms. Regarding the safety of genetically modified foods, e.g., the long-standing debates over Bt brinjal and GM mustard. 12. Regulatory framework in India. India uses a multi-tier statutory system to assess and manage biotechnology risks. Genetic Engineering Appraisal Committee, GEAC, operating under the Ministry of Environment, Forest and Climate Change, MoEFCC. The GEAC is the apex statutory body responsible for approving the commercial release of GM crops and food items under the Environment Protection Act, 1986. 13. Conclusion. To double farmers' income and build agricultural resilience, biotechnology must be deployed through a transparent, science-backed regulatory pathway. Balancing biotechnology innovation with biosafety evaluations ensures sustainable productivity gains for the rural economy. Strategy tip for UPSC Paper 3. When writing these answers in the exam hall, remember to draw quick schematic diagrams, like the 3-stage nuclear cycle or a hub-and-spoke model for space applications. This visually breaks up long text blocks and helps the evaluator grasp your core points quickly. Would you like to practice a question on India's national quantum mission or artificial intelligence policy?